Hello everyone, let's begin our lesson on pressure. Please make sure you have your handout next to you so that you can attempt the questions as we move along. In this lesson, we are going to learn what pressure is. We are going to look at some everyday examples and see how we apply pressure in our daily lives. And of course, we are going to learn how to do calculations involving pressure. Now, let's take a look at two scenario over here. This person is lying down on a bed of nails. This person is about to step on one nail. Which person do you think will be more seriously injured? If you look at this little girl, she seems to be enjoying lying down on the bed of nails, and she's actually not injured, not harmed. But for this person, we are pretty sure that it's going to be quite a bad injury stepping on a nail. So why is it that lying down on hundreds of nails, this person will not suffer any injury, whereas stepping on one nail, you will be, badly injured. So let's say this person is lying down on a bed of nails. All right, so you have many of the nails that the person is lying down on, and the other person is standing up. Let's say this is the feet, all right, and stepping on one nail. Now, let's assume that we are talking about the same person here. So therefore, because it's the same person, the weight is the same. Now, the force that's pulling the two persons down is the weight of the person. So in this case, the weight is pulling the person down. So in both cases, the weight is the same because let's say we are talking about the same person. However, now for this person that's lying down on a bed of nails, the weight is distributed over all the nails that's in contact with the person. So this is a much larger contact area compared to this person because the weight is all concentrated in the contact area of one nail with the feet. So therefore, this person is going to experience what we call a higher pressure. We will talk about the definition for pressure in a while. Okay, but meanwhile, just remember that when the force is distributed over a very small area, we say that the pressure is high. And when the force is distributed over a larger area, we say that the pressure is lower. So sometimes, or not sometimes, but so basically the same force can be applied, but the effect will be different depending on whether your force is spread over a large area or whether your force is concentrated on a small area. So your injury may not be due to the force in this case because they are the same. The injury is actually due to how big an area the force is applied. So to summarize, if the force is spread over a large area, then it results in a small pressure. If the force is spread over or distributed over a small area, it will result in a large pressure. So let's take a look at another example. Now, in this case, you see two bags, and again, I want you to assume that the weight of both bags are the same. So the force that's pulling the bag down, the weight, they are the same. But when you are carrying the bag, which one will you feel more comfortable? Now, from experience, we know that this haversack is going to be the bag that is actually more comfortable. So why is that so? Well, in this case, the weight of the bag is distributed over a larger area because the strap is thicker. But in this case, the weight is distributed over the very thin string, so it has a smaller contact area with your shoulders. And therefore, you can say that this is how you would answer to say that you are actually more comfortable carrying the bag with a thick strap because your weight is distributed, sorry, not your weight, the weight of the bag is distributed over a larger contact area with your shoulders. Now, I would like to emphasize the word contact area. The reason is because some students tend to like to write the word surface area or just area, which can be quite vague. Basically, what causes the difference is the area that's in contact with your shoulders. It is not the surface area. Now, surface area, I would mean this part here, the whole surface, right? Everywhere. This is the surface area. Now, this part has got no impact. This part has got no impact on the pressure that you feel. So, what will make the difference is actually which part, the parts that are in contact with your shoulders. So, it's important to use the word contact area. Let's take a look at another example. Okay, so you have a pair of stiletto and a pair of track shoes. Now, if the person wearing it steps on you, well, you will. I think we all would agree that this person, the one with wearing the stiletto, is going to cause more injury to your feet. So even if the person wearing the two pairs of shoes have the same weight, but this person wearing the stiletto is going to cause more injury. So why is that so? If you were to use the same example as the bag, again, you can tell that in this case, the weight is distributed over just a very small contact area here um, between the shoe and your feet. But over here, the area is distributed over a much larger, sorry, the force is distributed over a much larger area. And we mentioned before that when the area is bigger, your pressure is smaller. So this is how we will answer that the stiletto is going to cause more injury because the weight is concentrated over a very small area of contact. So remember the word contact is important in your answer. So from the two examples, you could tell that contact area has play an important role in determining your pressure. But of course, even if the contact area is exactly the same, okay, let's say the contact area is the same, but if you apply a very big force or if you apply a very small force, then the pressure will of course be different. Okay, so two factors that affects pressure, force as well as area. So let's take a look at the formal definition of pressure. Remember when the if you are asked to define a physics quantity or a science quantity, it is important to give a formal scientific explanation of that term. So most of the science terms, there is a formal definition. We are not asking for examples, we are not asking for a description. So do take a look at these terms that they ask and make sure you know what the definitions are. So for pressure, the definition is the amount of force acting perpendicularly on a unit area. So pressure is not force. Pressure is the force acting only on a unit area. So what is the meaning of unit area? Unit area means one. So 1 square meters of area. So if I were to tell you if I tell you the pressure, I'm actually telling you the force that is acting on 1 square meters of area. And that force is actually acting perpendicularly. So this is the formula for pressure. Um, Pressure is the amount of force that is applied on a body divided by the area in which the force is being applied. And if you want, you can also remember it with this formula. So F on top and PA below. So what are the units that's being used in this formula? It is important that when you are using this formula, you substitute the units correctly. Pressure is measured in Pascal, a capital P and small a. Do note that it is important that the P is uppercase and the A is lowercase. And another unit is newtons per square meters. There's a bit of error here. It should be newtons per square meters. So the unit for this is Pascal. or you can put newtons per square meters. They are the same because 1 Pascal is the same as 1 newtons per square meters. The force is in newtons, the area is in meters square. Later on, we will take a look at some of the calculation and then we can practice. So let's take a look at some of the examples that we see in our daily life. So if this person is carrying a bag with, well, it looks like 10 durians, and this person is carrying a bag of 5 durians. So what is the difference? Well, in this case, the force is definitely going to be larger because there are 10 durians over here. So it's the same person carrying, they are carrying the same bag. So the contact area is the same over here. But definitely this one will be more tiring to carry, isn't it? And more painful to carry because the weight is much bigger. This one, the weight is smaller. So the weight is actually the force that's pulling it down. So force will affect the pressure. The larger the force, the larger the pressure. Smaller the force, smaller the pressure. What if the force is the same? Well, if you are carrying the same bag, but you are carrying, well, it depends on how you're carrying it. So let's take a look. Now, in this case, the person is carrying the bag like that. So this is going to be more painful than if you were to wrap a piece of handkerchief. And the reason why it is less painful to carry like that is because the pressure is smaller. When you wrap with handkerchief, you are actually increasing the contact area. And the bigger the contact area, the smaller the pressure. So the other factor that affects is the contact area. Now let's take a look at some of the application again, more applications. So the example about the carrying the bags is to tell you what are the factors that's affecting pressure. So remember the force and the contact area. So both will affect the pressure. Let's take a look here. Now, you find that it is not difficult for us to actually push a thumbtack into your notice board. But if I were to ask you to use your finger to push into the notice board, you find that it is very, very difficult. You can't push and make a dent just like how you would do with a thumbtack. And the reason is because when you're using a pin like that, the contact area is very small. So again, in this case, because your area is very small, you can easily apply a large pressure. So with a large pressure, this pin can easily go into the soft board. Same thing, it is much easier to cut if your knife is sharp because a sharp knife has a smaller contact area with the food. So that again, with a small contact area with the food, you just apply a force and the pressure that results is going to be quite big. So that big pressure will make it much easier to cut your food. Injection, same thing. The needle is able to pierce through your skin because this area is small. So the pressure, again, the area is contact area with your skin is small, so the pressure is large. But there are applications where the contact area is large. And this can be demonstrated with a pair of skis. Now, when people go skiing, they are moving on snow, and snow is very soft. So if your pressure that you apply on the snow is large, you end up sinking into the snow. So if you don't want to sink, you have to make sure you apply a smaller pressure. Now, since we are not able to change our weight so easily, the next way to change our pressure is to change our contact area. So in this case, the contact area for the pair of skis is large. So this is when our contact area is large. And therefore, the pressure that you exert on the snow is going to be smaller. And with a smaller pressure, you can quite safely move you can quite safely move on the snow without sinking in. I think we have spoken about Stiletto a few times, so I will not say much about this. Car tires. So if your car tires roll over a nail that's on the floor, the tires gets punctured. So again, because the nail has a very small area. So with a small area, the pressure that it exerts on your tire can be quite big, and that can actually easily puncture your tires. Before I end this part one of the notes, I would like to say something about answering technique. Now, you will be frequently asked to explain about how pressure is applied in our daily life. If the question require you to do an explanation, do note that explaining something means that you have to support your answer with reference to some theory or definition. So in this case, because the topic is on pressure, when you explain, you must support it by writing down what pressure is. Okay, so for example, in this question, it says, explain why it is difficult for people who wear stiletto to walk on a field. So why is it difficult? Now at the back of our mind, we know that, oh, because, small contact area, large pressure, and so on. But before you write all this, you must give a definition for pressure first. Instead of just saying that, oh, small contact area, therefore large pressure, you must first tell them why is it that small contact area results in a large pressure. So this definition has to be written first. So I will write the definition and say that pressure is force per unit area. So since the area is small, and so therefore a small contact area, so therefore based on this formula, the pressure is large. And with a large pressure, you may sink into the field. And then this last bit here is what we call a link back to what the question asks for, right? So this will make walking on the field difficult. So this last bit kind of make the answer more complete. So do remember that when you are answering the question, you have to write down the definition for pressure. If you do not want to write the definition, you could also write down the formula. So which means you could also write down pressure equals to force over area. So you can replace this highlighted portion with this formula. But I would prefer if you write out the word force and area rather than just putting the short form like that. Okay,